So we're going to title our notes. We're in section 7.1. We're going to call this basic trig identities, but it won't feel basic. Okay. There's just a lot of little pieces that we need to put together here. And you guys, I'm going to refer to what you have. Have your formula sheet out in front of you. I'm going to refer to that instead of having to write everything on the notes because you have that with you. So first we have our reciprocal identities, right? And we've looked at that last unit that the reciprocal of sine is cosecant, the reciprocal of tangent is cotangent, the reciprocal of secant is cosine, right? And so we have some experience with that. If you forget, hey, you could look at this, okay? But we're going to first look at simplifying some things with reciprocals. And what happens when you multiply reciprocals together? You get 1. So like if I have 2/3 and I multiply 2/3 times its reciprocal, oops, that's not the reciprocal. If I multiply with the reciprocal, I'm going to end up with 6/6, and I get 1. What if it's a negative number? Will I still get 1? If I multiply with its reciprocal? Yeah, so like -3. What's the reciprocal of -3? -1/3. And when you multiply those together, you still get 1. So whenever you multiply reciprocals together, you get 1. So our first example here, we want to simplify the secant of theta times the cosine of theta. Well, the secant of theta and the cosine of theta are reciprocals of each other. And whenever you multiply reciprocals of each other, you get 1. And so look out for the reciprocals. It's going to help you as things get more complicated. Just keep that in mind. Okay, when you multiply reciprocals together, you get 1. Next example, the cotangent of theta times the sine of theta. Are those reciprocals? No. Okay, so this first one, I just want to take a little note here. So look for reciprocals. Okay, this one right here, what's a technique that you remember from last year? If you had something like this and you had to simplify, yeah. Change. Okay, so if it doesn't look like you can do anything to it, you can always change everything in terms of sine and cosine. And so let's try that. Cotangent is cosine over sine. Is that on your cheat sheet? That one's not on your cheat sheet, so that one you got to remember. Okay. Cotangent is cosine over sine. Oh, it is. I didn't see that. Okay, you even have that. Okay. And sine is sine over 1. And then we can simplify this, right, by reducing the fraction, and we end up with cosine of theta. And so remember, one good technique is to change everything in terms of sine and cosine. Next one, simplify tangent over secant. Now, because we have our reciprocal functions, we can always get rid of fractions pretty quickly. If if they're simple fractions. And the ones most of the things we'll see will be simple fractions. A fraction will not be simple if the denominator has more than one term. If the denominator is one term, I'll call that a simple fraction. Okay? Here our denominator has one term. So I can, if I have 1 over 3/5, how would you simplify that? That's the same thing as 1 times 5 over 3. And what I want you to see here is I can take whatever's in the denominator, move it to the numerator, and make it and put the reciprocal at that spot. Okay? So in this case, I could write this as tangent theta times what? Cosine theta. So if you know the reciprocal function, so I'm moving this to the numerator. Whatever you move to the numerator, just change it to its reciprocal function. And that's a quick way to get rid of fractions. Again, this is going to be a helpful technique for you as things get more complicated. And then once we're here, then we can use the second technique, change everything to terms of sine and cosine. And here, sorry, this is cosine. We don't want to get rid of our fractions, we just want to simplify. And so we end up with the sine of theta. And so here we can, it works the other way. If for some reason you want a tangent to move to the denominator, you could do that and you can change it to what? Cotangent. So you can move these things to the numerator or denominator just by changing it to its reciprocal. So that's what I'm going to write here. So we can move trig functions to the other side of the fraction. By changing it to its reciprocal function. Okay, simplify. Sine of theta, tangent theta, cotangent theta, cosecant theta. Answer? 1. Okay. Can somebody explain how they got 1? Yeah. Okay, so you changed to a fraction. So you used the method in C, and you would you move to the bottom of the fraction? You moved what? 2 sines and 1 cosine. Oh, you changed tangent to sine and cosine, cotangent to sine and cosine, and moved things around. Okay, that's what you did. Okay, that would work. And there's going to be multiple ways. Anybody use it another way? Yeah. This times this is 1. This times this is 1. Any other ways that you guys used? But anyway, however you do it, you want to get to 1. So answer's 1. Good. Okay, so next one, simplify. Secant squared theta, cosine theta, over sine theta cosecant theta. Answer? So 1 over cosine or secant theta. If you can get rid of the fraction 1 over cosine, do that. So you move the cosine to the top, becomes secant, right? The secant theta is what we want to get to. Again, there's a few ways to do that. One way is to say, okay, this is secant squared theta is secant times secant. This right here is 1. This right here is 1. You end up with secant theta times 1 over 1, which is secant theta. That's one way to do it. There's other ways as well, but you want to get to secant theta. Okay? All right. So in a Math 2 class, this would be, my notes would stop there on round 1. And keep going now. So these are kind of basics. Now we're going to throw in the Pythagorean identities. Okay, again, you have those there. And let me just give a little background. We know that if we have a right triangle with a hypotenuse of 1 and some angle theta, the side opposite theta is sine, and this would be the cosine. And if we use Pythagorean theorem here, we get the most famous Pythagorean identity, that sine squared plus the cosine squared is equal to 1. And you have that in your cheat sheet, right? Now, if we take that and we divide everything by sine squared, we can change the way that looks. So if I divide each of these pieces by sine squared, I get sine squared theta over sine squared theta plus cosine squared theta over, I'm just dividing each piece by sine squared theta, because you could do that with an equation. You can divide both sides of the equation by the same thing. But by doing this, it changes the type of function we're looking at. So what's sine squared over sine squared? What's cosine over sine? And what's 1 over sine? And you guys see that that's another Pythagorean identity. That's the second one. There's 3 of them. That's also on your cheat sheet. Okay. And so I'm just giving you a little background where they're coming from. And then the third one, what do you think you do to create the third one? Divide your original by cosine squared. So if I had sine squared theta plus cosine squared theta equals 1 and divided all 3 of those by cosine squared, and then simplified, you'd end up with tangent squared theta plus 1 equals secant squared theta. And normally I would, in my Math 2, I made them memorize all this stuff. You guys don't have to do that. So I normally talk about how to remember this stuff, but you don't have to worry about that. What you do have to worry about, though, is all the variations of these. For example, because sine squared plus cosine squared equals 1, you can rearrange that. Okay, so if I have sine squared theta plus cosine squared theta equals 1, what would cosine squared theta equal? So you use this equation to solve for cosine squared, and you just subtract sine squared from both sides, and you'd say, well, then that's going to be 1 minus sine squared, right? as long as you're aware of this kind of thing, because this is going to happen a lot. And the examples I'm going to give are going to use this kind of stuff. Okay, so let's pick up again with our examples on F here. Simplify cosine squared theta over 1 minus sine squared theta. The thing that should trigger Pythagorean identities is if you see anything squared. If you see any of your trig functions squared, always think, hey, can I use one of these Pythagorean identities? And here everything's squared. And when you're simplifying, you're going to focus more on something that's not as simplified. So in this fraction, the denominator is what I'm going to focus on first. Is there something, can I use a Pythagorean identity and replace 1 minus sine squared with something that's equal to it? Well, we just did that right there, right? We saw 1 minus sine squared is cosine squared. And so then we end up with 1 as an answer. All right, simplify sine squared theta plus cosine squared theta over cosine squared theta minus 1. Try that. We're focusing on the Pythagorean identities, so you're going to want to keep those in mind as you're working through these. So sine squared plus cosine squared, we got to know is 1. And again, you can see that on your cheat sheet. But the other one is a variation, right, of our sine squared plus cosine squared equals 1. What is cosine squared minus 1 equal to? Nice. Okay, and if you didn't see that, so we got sine squared theta plus cosine squared theta equals 1. And if I want to create a cosine squared minus 1, I leave my cosine's positive, so I'm leaving that there. I need to move the 1 over to get the minus 1. And then I need to move the sine over to the right. So I end up with cosine squared theta minus 1 is equal to negative sine squared theta. So that's what I mean by you got to move things around in those equations to get equivalent expressions. So negative sine squared theta. And then what's this going to be? Move this to the top of the fraction by putting its reciprocal, and you get the cosecant of theta, and it's still squared. So that's what you're going to simplify to. When you're simplifying, if you can get rid of fractions, you're going to get rid of fractions. So that's part of the idea of simplifying. H, simplify 5 sine squared theta plus 5 cosine squared theta. Yeah, I heard some of you say it's 5. Why? Factoring. Okay, if you factor out the 5, what's left is sine squared theta plus cosine squared theta, and that's your identity that says that's equal to 1, and you get 5. You doing okay? Am I going too fast? Okay. Next one, simplify. Sine squared of 2x minus cosine squared of 2x. But this time, what do we mean by simplify? I want you to get it all in terms of sine. In other words, get rid of the cosine. Now notice the angle is not theta. Angle's changed to 2x, but don't let that bother you. That will always be there. It's just an angle. The angles don't change right now. We'll change them later, but in the basic trig functions, they're just going to stay what they are. So what you should see here is sine squared minus cosine squared. You kind of glaze over. As long as the angles are the same, that's all that matters. You just focus, okay, this is sine squared minus cosine squared. I want to change this so that it's only in terms of sine. See if you can do that. Use your Pythagorean identity. Question. Anybody have any success on this one? Equals 0? No. So anybody have trouble on this one? Okay. So if you're trying to make a Pythagorean identity, say sine squared minus cosine squared, it's not going to work, right? But you don't necessarily have to get rid of both of them. All you need to get rid of is cosine squared. And can you replace cosine squared with something else? Well, in terms of sine, you want to keep it in terms of sine. So we know the Pythagorean identity sine squared plus cosine squared equals 1, right? And if I solve for cosine squared, what do I get? 1 minus sine squared. So I can replace the cosine squared with 1 minus sine squared. And that gets rid of your cosine and puts it in terms of sine. So it's going to look like this. Sine squared 2x minus, in parentheses, 1 minus sine squared 2x. Right, just replacing the cosine square with something that's equal to it, and then distribute the negative, and we get 2 sine squared 2x plus 1. Minus 1, sorry, yeah, minus 1. Okay. Was that the first tricky one? Okay, but just remember, you can do stuff like this, okay? Next one, simplify 1 minus sine squared over 1 minus cosecant squared. On this one, can I take the cosecant and move it to the top? No. You can only do that if there's one term in the denominator. How many terms do I have in the denominator? 2. Terms are separated by plus signs and minus signs. So if you have more than one term, you cannot use that trick to get rid of the fraction. But everything's squared. Well, you have sine squared, you have cosecant squared. So look at your Pythagorean identities, see if those can help you out. Bless you. Did anybody figure out what to replace 1 minus sine squared with? Cosine squared. Did anybody figure out what to replace 1 minus cosecant squared with? Negative cotangent squared. Does anybody need to see how we came up with these? Okay, so the Pythagorean identities, these right here, these 3, okay, they all have squareds, and if you're dealing with like a secant squared, there's only one of them that has a secant squared, so you know which one you're going to use. If you're dealing with a cotangent squared, there's only one with a cotangent squared, so you know which one you're going to use. And so in this case, bless you. So this has a cosecant, and we know that 1 plus cotangent squared is cosecant squared. That's on your formula sheet. And so then you're going to say, hey, can I make 1 minus cosecant squared out of this? And if I move the cosecant over, I have the 1 already there, and I move the cotangent over this direction, I'm going to get 1 minus cosecant squared theta is equal to negative cotangent squared theta, and that's where that's coming from. Okay. Same idea with the 1 minus sine squared. I think we've done that one before, so I'll leave that there. So from here, it would be nice. Now I have one term. I'm going to move it to the top by changing it to negative tangent squared, and I have a cosine squared. And then I'm going to use a technique where I change everything to terms of sine and cosine. So tangent is sine over cosine. They're both going to be squared. And I have a cosine already, and that's by default over 1. And you reduce, and you get negative sine squared theta. Okay. So this is still Math 2 review right now. Okay, just reminding you what we've done already in Math 2. Okay, we got one more Math 2 one here. So secant squared of 3x minus tangent squared 3x brackets times cosecant squared 3x minus 1 all over tangent squared, sorry, sine squared of 3x minus 1. Simplify that. Again, the 3x is just an angle. As long as all the angles match, you can ignore them and just carry them along with your work. Secant squared minus tangent squared is 1. Okay, that's nice. Secant squared, so this whole thing is 1. Okay, so you don't have to worry about it. Is it? Yeah. And it comes from the Pythagorean identity. How about cosecant squared minus 1? What is it? It's cotangent squared 3x. And then sine squared minus 1 is negative cosine squared 3x. So this thing simplifies down to the cotangent square root of 3x over the negative cosine square root of 3x. I'm going to move this to the numerator. I'll move it in front because it's got a negative sign with it. And it becomes negative what? Secant square root of 3x times the cotangent square root of 3x. And then I'll change everything in terms of sine and cosine. And I get negative 1 over cosine square root of 3x times cotangent is what over what? Cosine over sine. So we still have a negative sign. We get negative 1 over sine square root of 3x, which is negative cosecant 3x squared. Okay. So that would be day 2 of math 2 notes. Day 3 now. You need this to even do the first half of the first homework. All right. So the next thing I want to talk about is a couple more techniques, a little more advanced techniques than we've been looking at. And that's multiplying or factoring within the trig functions. So we simplify sine cubed theta cosine theta plus sine theta cosine cubed theta. Okay, try that. Use factoring to help you. You see something that can factor out of, how many terms do I have? Let's say start there. 2, because terms are separated by plus signs, right, or minus signs. What do those 2 terms have in common that we can factor out? Sine and a cosine. And so then we're going to be left with 2 terms after we factor that out. What's the first term? And do you see what to do next? That is a Pythagorean identity. Change that to 1, and you're left just with sine, cosine, and there's nothing else to do after that. Okay. Let me give you just one more example for today. So factoring can help. That's what that one's showing you. Cosecant x minus cotangent x times cosecant x plus cotangent x. Simplify that. So here I want you to multiply, because sometimes factoring helps. That's what L's showing you. Sometimes you got to multiply. That's what M's showing you. So multiply it out and see if you can simplify it. For homework, I'm just going to assign you the first page 1 through 14. You'll have enough trouble with that page. Okay, it'll be challenging. It's not going to be due until Friday either, because tomorrow we're meeting in the library. But you need to start thinking about this stuff. I've given you enough, and then we'll continue with more examples on Friday. Okay, and they'll get more challenging examples then. Okay.